Hi class, for this video I want to introduce more complex problems of integration. So we need something extra when we have to deal with those two complex problems. So for example, let me just show you an example. So for example, this one right here, 2x square root of 1 plus x squared dx. If without the square root, the first thing we would do is we distribute and then we just proceed the problem and take the antiderivative, right? So we can only take the antiderivative if the polynomial just nice, like one term plus one term plus one term plus one term. But this one right here, you have a binomial, you have two terms. So you can't really just go straight into antiderivative. And then, so we have to introduce something extra. So that something extra is called the U substitution. So I'm gonna let U equals to 1 plus x squared. And then if I take the derivative du, I'm gonna end it up with 2x dx. And then you can see right here, 2x dx is 2x dx in the problem. I just rearrange. You see that? So now you see that we have the first part, the square root of 1 plus x squared, that part is u. And then du is 2x dx. So that's why we need to introduce u. So we can just make the problem simpler, and then you can just proceed with the antiderivative right there. And then when you're done, you put it back into the original equation, which is 1 plus x squared. I'm sorry, the original expression, 1 plus x squared. So that's called the substitution rule. Okay, so if you see, it's more like a composition with chain rule. So you see we have f of g of x, and then you have the chain rule inside. You have the g prime of x. You should work with f of u du instead. Okay, now not all problems gonna lay out nicely for you like that. So let's take a look at example 1. So you see in example 1, we have x cubed and we have the cosine of a big thing, right? Now I can't really combine those two. I can't really distribute. So I'm gonna let u equals to x to the 4th plus 2. When I take the derivative, I'm gonna end it up with du equals, let me do that. I'm gonna get du equals 4x cubed. Now the problem is, in the original problem, I only have x cubed. I do not have 4x cubed, right? You have, right here, you have x dx, x cubed dx. But right here, you have that 4. So what can we do? We can get rid of it. We're just gonna divide by 4. You see that? So now, 1/4 du is going to be x cubed dx. That's exactly what we need. So when you plug it in, it's like that. You take out the 1u, or take out 1/4, and we ended up with 1/4 sine u plus c, and then I put it back. All right. So pretty much this one right here, you have to divide by 4. So to get it back to the original. Okay, so we pretty much have to make them the same. Okay, all right, so let's take a look at example 2. So example 2, when I look at the problem, I go straight and say, okay, u is going to be dx, 2x plus 1. Therefore, du is going to be 2 dx. Now that's the problem, because in the original problem, I only have dx. And now I have that 2 right there. That's 2 dx, okay? So how do I do it? How do I change it? I'm gonna have to divide by 2, right? Divide by 2. And then I can just proceed with the problem. Okay, So we have, okay, let me just copy the problem. 2x plus 1 dx is going to be the square root of u. But then we have that 1/2 here. So 1/2 times du. All right. You can definitely take the 1/2 out. So we can take the antiderivative this way. So now the problem got easier, right? So we know how to take the antiderivative here. 1/2. And then the antiderivative of that is going to be u 3/2 divided by 3/2. I can simplify later. Plus c. So if I multiply by the reciprocal, 2 and 2 cancel out. So I ended up with 1/3 u to the 3/2 plus c. All right, and then you can just put it back. 1/3 2x plus 1 to the 3/2 plus c. Okay, and there you have it. That's your answer. Okay. All right. So let's take a look at example 3. Okay. So I would say the first thing we should do is we should look for, I'm sorry, the dx should be up here. Not like that. It should be up here. Okay, so when I look at a problem, like I said, I would pick the more complex and call it u. So u should be 1 minus 4x squared. And then when we take the derivative, you ended up with negative ax, right? Dx. We have x dx. Over here, you have negative 8x dx. So you know that we have to get rid of that 8, negative 8. So I'm just going to divide by negative 8, divide by negative 8, like that. Okay. So now the new problem is going to be, you know what, we can always take the constant out from the very beginning. So I'm just going to take the negative 1/8 out. So now we have 1 over square root of u du, right? Let me just bring it to the top and make it easier to take antiderivative, okay? So now when I take the antiderivative, I'm gonna end it up with negative 1/8. Negative 1/2 plus 2/2 is gonna be 1/2, and then you divide by negative 1/2, so it's multiplied by 2. There, plus c. So we can simplify this part right here, 1/8 or negative 1/8 times 2 is negative 1/4. And then I can put it back. Instead of u, we have one plus 4x squared to the 1/2 plus c. Okay. Don't forget, you can always check your answer by taking the derivative, right? Because we do an antiderivative here. All right. So let's take a look at number 4. Number 4 right here, as you can see, 5x should be u, right? Eventually, when you look at the problems, you will know right away which one is u, okay? So u equal 5x, okay? So du, straightforward, it's just 5 dx. So you can see that we don't need that 5. So I'm just going to divide by 5, divide by 5. All right. So I can take that 1/5 out from the very beginning, 1/5. And then instead of e to the 5x, we have e to the u, du. Okay, so it's going to be 1/5 e to the u plus c. And then we know that this is just 1/5 e to the 5x plus c. Okay. All right. Eventually, when you do the problem over and over again, I think you can recognize the extra part right away. So you actually don't have to say, oh, I'm going to let u equal to something. When you look at the problem, you can see that, oh, you know what? E to the 5x power. And then when I take the derivative, I'm going to get e to the 5x times 5. So you can see right away 5 is something we have to get rid of. So you can just divide by 5, right? So I can go back to the same problem. So from example 1 to example 4, you don't need to use u if you can see the problem right away, right? So for example, I have, the example 1 that I forgot. So it's this one, x cubed cosine x to the 4th plus 2 dx. Okay, so when you look at the problem, you try to take derivative of that. And then if you take the derivative of that, you should end up with 4x cubed. We have that x cubed and that x cubed here. So you know that 4 is something that you have to get rid of. Okay, so from the very beginning, you can just put 4 outside. So 1/4 like this, because I have to get rid of it, right? So 1/4, and then I have 1/4 cosine of x to the 4th plus 2 times 4x cubed dx. Because 4 is something we need to get rid of. Okay, so you see right here, they're exactly the same, right? So you just have to, take the derivative. So we have 1/4 here. Cosine of x to the 4 plus 2 times d over dx of x4. I'm doing chain rule. Dx. Okay. So you know that when you take the derivative here, you ended up with 4x cubed right here. Right? So we know that the answer is just going to be sine x to the 4th plus 2 plus c. So that 1/4 is from this part. Okay, and then you have to have the x cubed there, because don't forget, when we take the derivative, we get 4x cubed. So x cubed has to be there.